Welcome to the Intelligent Founder AI podcast. This is episode 18, and it is also the final episode in the very first Build, Buy, Rent series. Over the last 8 episodes, we have tried to do something quite specific. Not to add to the noise around AI and not to treat every new model, benchmark, or product release as a strategy in itself. Instead, we have looked at the practical decisions founders have to make when they are building with AI right now. We have talked about where AI creates genuine value and where it does not. We have discussed the difference between a useful prototype and a reliable product. We have looked at agents, automation, the build versus buy question, model selection, data, evaluation, deployment, economics, and adoption. And underneath almost all of those conversations has been one quieter question: who controls the compute? Because compute is not merely an infrastructure line item. It determines what models you can use, how quickly you can iterate, what latency you can offer, whether sensitive data can stay local, what your product costs to run, and ultimately what kind of business you can afford to build. So this final episode is about Nvidia, the compute wars, and what they mean if you are building an AI company today. But it is also a conclusion to the series, because if there is one theme that connects all the episodes, it is this: successful AI companies will not win merely by having access to a powerful model. They will win by making better choices about how technology becomes a reliable, useful, and economically viable product. So why the old framing changed? When I first outlined this episode, the headline was Nvidia's data center revenue reaching $51.2 billion in a single quarter. That was already extraordinary. But the market has continued moving at an extraordinary pace. Nvidia later reported $75.2 billion in data center revenue for its latest reported fiscal quarter. That was up 21% from the previous quarter and 92% from the same period a year earlier. Those are enormous numbers, and they are not just an Nvidia story. They show that accelerated compute has become foundational infrastructure for the AI economy. Training frontier models, serving generative AI products, building agentic systems, processing multimodal data, operating robotics and industrial AI applications. Every one of those things puts pressure on the underlying compute stack. So yes, Nvidia is a company, but it is also in many ways infrastructure. And when a company becomes infrastructure, its commercial decisions, supply constraints, software ecosystem, and hardware roadmap affect everyone building above it. Let's talk about Nvidia's moat. It is tempting to explain Nvidia's position simply by saying it has the best GPUs, but that explanation is incomplete. The more durable advantage is the ecosystem around the GPU: CUDA, software libraries, compiler support, optimized kernels, networking, systems design, documentation, training material, research code, and millions of developers who already know how to work in that environment. And this matters because moving from one compute platform to another is rarely as easy as a slide deck suggests. A model might run on another accelerator, but can you reproduce the same quality? Can you match the throughput and latency? Can you use the same serving stack? Do your engineers know how to debug it? Do the tools you rely on support it? Can you measure it consistently? How much migration work will that create? That is where the moat sits. Not in the fact that nobody else can build a powerful chip, but in the accumulated time, knowledge, and tooling required to make alternative hardware productive. For founders, that means two things can be true at once. First, Nvidia is likely to remain the default choice for many demanding AI workloads. Second, default does not mean mandatory. I also did 2 deep dives on Nvidia: the Nvidia AI Factory, roadmaps, risks, and future dominance, and Nvidia opens Pandora's model in Markets Insight section. So to check those out for a more detailed moat discussion. Now let's talk out. The alternatives, which are increasingly real. AMD remains the most credible broad GPU challenger. Google TPUs can be compelling for particular workloads, especially within Google's ecosystem. AWS Trainium and Inferentia offer a path to lower-cost training or inference for compatible models. And specialist GPU clouds can sometimes provide capacity, flexibility, or economics that a hyperscaler does not. But there is an important word there: compatible. You should never assume that a lower advertised hardware price translates automatically into a lower production cost. The true cost includes engineering time, migration effort, model compatibility, operational support, utilization, latency, reliability, and the cost of changing direction later. AWS, for example, has published customer examples of significant savings, around 50% in some cases when workloads move to Inferentia. That is encouraging, but it is not a universal promise. The saving depends on the workload and on the work required to get there. That is why founder question is not, which chip will win? The better question is, which platform gives us the lowest total cost of delivering the product experience our customers need? That is a different kind of decision. It is more empirical, more disciplined, and much less influenced by hype. Another thing that has changed is the simplistic view that compute prices will simply fall over time. Some prices will fall. Older hardware becomes more available. Competition increases. Better scheduling, spot capacity, reserved commitments, and specialist providers can improve economics substantially. But premium capacity can also become scarce again, quickly. A new class of models, a wave of large training runs, a shift towards agentic products, or a rush for a specific accelerator configuration can alter availability and pricing faster than a quarterly plan can adapt. So do not build your business model around an assumption that GPS will always become cheaper in a smooth and predictable way. Treat compute pricing as volatile. Benchmark your options. Understand your workload. Track actual cost per useful output, not only cost per GPU hour. And build enough flexibility into your architecture that you have a credible second path if your preferred provider becomes too expensive, too constrained, or simply no longer the best fit. That is not full infrastructure agnosticism. In reality, very few serious systems are perfectly portable. It is practical optionality. It means your application is not hopelessly entangled with one provider's proprietary features before those features have proven their value. It means you have a reproducible evaluation suite. It means you know what quality, latency, and cost look like on at least one alternative path. And it means you can make a rational choice when the market moves, rather than an emergency choice. The important point is not the headline numbers anymore. The important point is that local AI development is becoming more capable. Not necessarily as a replacement for cloud infrastructure, but as part of a more flexible architecture. For founders, this can mean faster private experimentation, more control over sensitive data, on-premises prototyping, edge deployments, and a lower friction route to validating an AI workflow. This is particularly relevant in regulated sectors, industrial systems, critical infrastructure, and any context in which sending data to a public cloud is difficult, expensive, or undesirable. The future architecture may not be cloud or edge. It may be cloud for large-scale training, local systems for development and experimentation, and edge or on-premises inference where latency, privacy, or resilience requires it. So what should a founder actually do? I think of compute as a staircase. Rent, optimize, commit, then own or operate where the evidence demands it. At the start, rent. Use AP-IS managed model services or on-demand infrastructure. Your objective is to discover whether users care about the workflow. Do not acquire infrastructure commitments before you have evidence that the product deserves them. Then optimize. Measure your quality, latency, and cost. Test smaller models. Use routing. Apply caching. Batch requests. Quantize where it makes sense. Build an evaluation set that tells you whether a cheaper approach is good enough. This is where many teams leave value on the table. They jump from a prototype directly to expensive capacity when the more valuable work is often making the workload itself more efficient. Then, when demand becomes predictable, commit. That might mean reserved capacity. It might mean a managed partner. It might mean dedicated instances. It might mean a volume agreement. But commit only when your utilization data supports it, and then only for the right workloads, own or operate. There are cases where dedicated or on-premises hardware makes perfect sense. High volume, sensitive data, strict latency requirements, resilience needs, or an edge environment where connectivity is limited. But it is not a badge of seriousness. It is an operational decision. You are exchanging flexibility for control and potentially for better long-term economics. The right time to make that exchange is when evidence supports it, not when a hardware roadmap, a funding round, or a fear of missing out makes it feel urgent. This is where the compute conversation connects back to the rest of the series. Across these episodes, we have returned to the same disciplines. Start with a problem that matters. Do not confuse a model capability with customer value. Prototype quickly, but treat reliability, evaluation, data quality, and adoption as core product work. Know when to build and when to buy. Measure the economics before scale makes poor assumptions expensive. And keep enough flexibility that you can adapt when the technology changes. Compute brings all of those ideas together. The wrong infrastructure choice can make a product slow, costly, fragile, or impossible to deploy in the customer environment. But the wrong approach is not simply choosing the wrong chip. The wrong approach is making an irreversible infrastructure decision before you understand your workload, your users, your volumes, and your economics. The right approach is to use the best available option for today's product requirement while keeping a credible path to change tomorrow. Final thought: the compute wars will continue. Nvidia will remain a central force. AMD, TPUs, Trainium, Inferentia, and specialist clouds will keep increasing the number of credible choices. Local and edge AI will become more capable, and the combination of models, hardware, and deployment options will become more complex, not less. That should not intimidate founders. It should remind us what the job is. The job is not to predict the winner of every technology cycle. The job is to build something useful enough that it deserves to scale, and disciplined enough that it can benefit from new technology without being trapped by it. That is the conclusion of this first Intelligent Founder AI series. Thank you for listening, sharing, questioning, and building alongside these conversations. And most importantly, keep the product close to the problem, keep the system close to the evidence, and keep your options open long enough to make the right decision. Thank you for listening, have a great Sunday, and see you in the next episode.